Thank you, Limbo, for the introduction. Thank you all for joining me on this workshop. So in this workshop, I will introduce you some methods to incorporate the text data in structural equation modeling. Um, some of you may took the SEM workshop. Um, I think it's on Friday. So here I will give you only a brief introduction to structural equation modeling. After that, I will talk about text data with a focus on different methods to extract the information from text data. And then I will talk about how to fit SEM models with text data. I will also introduce an R package, text SEM. So I miss a T here. And an online app called BigSEM. So you can conduct the SEM analysis with text data using either the R package or the online app. I will demonstrate how to use this through several different examples, and I'll end with a brief discussion. So as we know, structured equation model is not just a single model, it's a collection of different models. It can include the regression models, median models, fact models, and mimic models. I'll give you some examples shortly. It's a method that can synchronize different models in the same general framework. Because of that, it can be very flexible. Even if you are not familiar with the technical part of the SEM model, we can extend the model. We can build our own model based on the general rules and the general methods. So because of that, it frees researchers from fitting or estimating a model to focus on building a model. As we know, as an early age of statistical methods, each time we propose a model, like a regression model, t-test, we need a way to estimate the model to conduct a statistical inference. However, SEM basically combines those different methods together, so we can also conduct many different data analysis within the same framework. So therefore, we don't need to worry about how to estimate the model, how to make the inference, but we use a tool or SEM program software to estimate the model. And also, like the SEM model is you are using Lego. It has different building blocks. You can build a different model based on like your theory, and then you can directly estimate the model in the general framework. So for example, this is the regression model. And in this regression model, we have four different predictors, x1, x2, x3, and x4. The outcome variable is y. So this is called a path diagram. It's a representation of a general model or SEM model. So here we have paths from x1 to y, which means x1 is a predictor of y. And the coefficient of beta 1 here, so that's basically the regression slope of x1 on y. Similarly, we have x2 to y. So x2 is a predictor, x3, x4 are also predictors of y. So therefore, this is a multiple regression model. There's also a triangle here with coefficient beta 0. So this basically is the intercept of your regression model. And if you are familiar with the mathematical model, you can write this model out as this. So y equal to beta 0 plus beta 1 times x1 to plus x beta 4 times x4. Uh, in general, like you could add a residual part to your model. Here I excluded that. The reason is in SEM model, you don't need to explicitly specify this. The software program can typically take care of this. So this is a regression model. They can be written as a SEM model. Another very popular model in social science is called mediation model. In mediation model, we have at least three variables. So here, this is an example to look at the association between mass education and the mass achievement of children. So basically, we know there's an association between mass education and mass achievement of, of children. But we want to know if there's a variable to explain this relationship, so when they are related to each other. And we may look at a variable called the home environment. So in this case, home environment plays an intermediate role between mass education and math. So which means we may hypothesize that mass education will change the home environment, and the home environment is related to mathematical achievement. Okay, so in this situation, the home environment is a potential mediator. And in this mediation model, from mass education to math, so this is called direct effect. I'm going to spend a little bit more time on this because later on I will feed a SEM model with text data, whether the text data is a mediator. Okay, so this is called direct effect. Okay, and the effect from mass education to mass achievement through home environment is called indirect effect. So which means this is how math education influence math indirectly through a third variable here. Okay. The indirect effect is often calculated as the multiplication of the two passes here. So that's basic alpha times beta. So this is called mediation effect. Okay. There are many different ways to test whether this mediation effect is significant or not. For example, one way is we can use the Sobel test. So the direct test, not hypothesis, um, the multiplication of the two coefficients is zero. Okay, certainly like more often we are using bootstrap methods now. And we can also write this mediation model using equations. So here, home environment equal to alpha. So this coefficient times mass equation. The mass equal to beta times home environment plus gamma times mass education because there are two passes goes to math here. Another thing I want to point out is, so this model is also a multivariate regression model, right? We have two outcome variables rather than just one outcome variable in the previous multiple regression model. This is another example that can be considered as the special case of SEM. So this is a fact model. In this fact model, we have two latent variables, intelligence and health. Those variables are typically cannot directly observed or directly measured. For example, it's very hard for people to see like how harassed they are, right? And oftentimes we use some like quantifiable like variables, so we can easily quantify those variables and then get the data. For example, we can use physical data like BMI, body mass index, and we can also take the blood pressure of people and get the heart rate. Okay, those variables combined together can be used as a measure of health. Okay, um, certainly there's different ways to combine this. Like one way is you can directly create a composite score from this, and another way is to use fact models. So we extract the fact score from this. So the fact score basically is a common variable underlying these three variables. Okay. Similarly, for intelligence, we can use three different variables to measure that. So we can give them give participants a math test, a verbal test, a reasoning test. So based on this, we form this score. And those two latent variables can also correlate with each other, as here. So if we want to write out the model using equations, looks like this. So we have six different equations. So this is can be viewed as fact model with a single factor. So this is the fact model with uh, a fact house. Okay. Those coefficients here are now called fact loadings. You may notice that the format of this is very similar to a regression model as I showed you earlier, right? But the only difference is in this model, the intelligence variable is unobserved, so it's not a part of our data anymore. But in regression analysis, those variables are observed. Using the fact model or SEM model, we can estimate this score actually. So this is another example called mimic model, called multiple indicator multiple cause model. The idea of this model is, as just like before, sometimes we cannot directly observe something. We can use indicators to get the information about the latent variable or latent construct we are interested in. Here, R is called reasoning ability. So it's one kind of cognitive ability we want to measure. We can use three sets of tests to measure reasoning ability. So those are three test scores. And from it, we can get the fact score for reasoning ability. But we may be interested in what factors are related to the reasoning ability. Okay, those factors are not latent factors anymore. You may think about what kind of variables are related to reasoning ability, or what can predict reasoning ability. So now we can consider two possible predictors or covariate. So one is education, another is gender. Maybe higher education will lead to higher reading score. That could be a potential hypothesis. Um, to write out this model using equations like this, so this is the fact model part. This is the relationship between the cause of these latent variables. So that's why it's called a multiple cause model. Okay. And previously we only focused on the cross-sectional data collected at a given time. The SEM models can also be used to analyze longitudinal data. So this model called cross-leg panel mediation model. So in this pattern mediation model, we have data measured at three different times, like time one, time two, and time three, right? For input, mediator, and output, all of them are measured at three times. So in this situation, we could look at the time sequence in the relationship. For example, um, in a mediation model, maybe like it's more natural, we believe X1 will first happen, right? Then it will influence mediator at the next time. Then the mediator will influence the outcome the time like after the mediator, right? So in this case, the mediation effect will be this path and this path. Okay. So this may reflect the idea of mediation effect better than the cross-section mediation model. Okay. And now this is also very popular model used in social science, particularly in psychology. So all of those models I discussed previously can be written as a special case of a sequence of equations like this. So this is called a least square model, so linear structure relationship representation model. Certainly, we can also expand this model for nonlinear relationships. But now, let's focus on this model first. In this least square model, we have two parts. One part is called measurement model. Measurement model, like again, like previous I mentioned, we may not measure some latent construct directly. We need the indicators, right? So the measurement models basically used to estimate the factors. So here we have cosine, we have eta latent variables, right? So X are the indicators of this set of factors. Y is the indicators of this set of factors. On top of that, we can look at the association or relationship among the latent factors. Okay, So that's the third equation. It's called a structure equation. Structure equation more like a multivariate regression analysis. And if you only have one eta, so basically it's a multiple regression. Okay. Notice that we call like eta as dependent variables or endogenous variables. Uh, cassette is called latent independent variables or exogenous variables. So you may just view this as I could say as like predictors, right? Eta as outcome variables in regression analysis, right? Certainly, you don't have to distinguish them sometimes. For example, if you use like Banner's methods to represent the model, you don't really need to distinguish them. Uh, so those are the mm, this is the structure model. So we can look at the relationship between eta itself. So it represented by the coefficient in this beta matrix. To look at the association between cassette and eta, we can look at the gamma matrix. Okay, so in this model, we have a lot of different parameters. We have a fact loading matrix here, uh, fact loading matrix here. So we have structure parameters here, and we also have the variance, covariance parameters for this error part or the residual part. Okay, so therefore, this model can have a lot of parameters, right? But the advantage of this model is for every model I talked about earlier, we can read the model in this case, in this way. Okay, uh, the advantage of we read out the general model is we can develop a estimation method based on this general model, which means a general, like for example, maximum likelihood estimation method can be developed on this. So if we have method available for this general model, certainly we can estimate a simpler model, right? I already showed you like the path diagrams. So in SEM analysis, oftentimes we use path diagrams to represent a model. The reason we use this is because it can help us um, better understand the association or relationship among factors and observed variables. Right? And in a path diagram, oftentimes we use squares or rectangles to represent the observed variables. Observed variables basically is the information in your data set. You should have that variables list in your data file. And we can use circles or the ovals to represent the latent variables or factors. So those are variables we don't have the information in our data set. Okay. It can also be errors, the residuals we talked about earlier. Then we have like arrows here. You notice that we have one-handed arrows and two-handed arrows here. Typically, the one-handed arrows represent the regression relationship or regression coefficient. There's another set of um, one-handed arrows that represents like a fact loadings. For fact loadings, it's an arrow from the latent variable to the observed variable. Okay. In this case, those are the uh, fact loadings. Other than this, we typically call them like regression coefficients. Uh, the two-headed arrows, there are also two types of two-headed arrows. One is on a single variable, like this, or this. So this typically represents the variance or the residual variance of your model. Okay, and there may also like two-headed arrows between two variables here. So this is called covariance. So that's basically the covariance between X1 and X2. So you may think about, remember like earlier we talked about the covariance between intelligence and health. So that's the covariance. There are many different ways to draw path diagram. So for example, you can use PowerPoint to draw the path diagrams. Like there's some software programs can also generate the path diagrams for you. We also develop some like online apps. So using these online apps, you can draw path diagrams. For example, one example is uh, we call the SEM diagrams. So you can click those different buttons and draw the path diagram. For example, click circle you get a latent variable. Click the square, you get the observed variable, and then you can draw a path between two variables, uh, like this. Okay. But there are many other programs available you can use to draw path diagrams. The reason I introduced this is because later on, I will show you an online app we developed. So it allows you to draw path diagrams to conduct SEM analysis with text data. And if you have any question, you can just type that in chat, and Nimble will moderate the questions. Okay. Traditional, like in ICM analysis, we simply focus on continuous variables, like numerical variables. But nowadays, like there are more general latent variable modeling framework. Rather than we call it least variable model, we call it latent variable modeling. So it can handle like all kinds of data. Beyond the continuous data, we can also handle categorical data. We can handle like count data, survival data. Um, so those kind of models also allow you to have categorical latent variables. So in this case, we may have latent class analysis, or we may have mixture modeling, mixture SEM. Uh, but this still very short on uh, newer types of data. For example, text data. We have network data. We may have image data, like photos. Text data is indeed to text data like the image data now is one like frequently collected data. For example, you may take a video like based on class observation. In like fMRI, you may have like um, a scan like images of brains. But here we focus on how to deal with text data. Um, in real world, I would argue there's more like qualitative data than quantitative data. Also, quantitative data is often analyzed using different statistical methods. Uh, a simple example here is like in my slides, all the information is represented by text, right? Also, like when you read a newspaper, when you go online with the website, oftentimes the information is shown as text information rather than values or the numbers, right? Qualitative data are also very widely collected in research and maybe like more often than you thought. It can come from different like sources. For example, in dairy study, the daily record can be collected, right? Can be written down like in a diary in a book, right? For example, you may ask like your participants to write down their activities and feelings of a given day, right? So this kind of information are text information. Text information can also come from the transcriptions of audios and videos. In education settings, we often observe how kids like learn, how like teachers teach. So in this case, we may have audio and video information. We can transcribe this information into text. Um, there are a lot of this kind of information. The reason is because like those audio transcription is much easier because there are like AI like methods to transcribe videos nowadays. Even for data collected through surveys and questionnaires, oftentimes when we have open-ended questions, we ask the participant to freely respond to those questions. For example, like in teaching evaluation, at the end of the survey or questionnaire, we often ask, do you have any other suggestions for the instructor to improve, or do you have any concerns? Um, so this kind of information are also in terms of text. Uh, Compared to the quantitative data collected typically through like Likert scale, the text data can also provide a lot of more information than a single number. For example, when you ask like people, how do you feel today? They may say like they feel very happy today or they feel very sad today. They may even rate like on a scale from 1 to 5, right? So they give you a single value. But when you collect like text data, the participants may like elaborate on why they feel happy that day, why they feel like sad that day, right? So this can provide like extra information than the numerical ratings. And another advantage may be like when we use leaked scale, sometimes like we may understand that different people may understand the scale differently, right? For example, your score 3 may be very different from my score 3. Like we found that in teaching evaluation too, some students give us give a score like 4 out of 5, but when in their comments, they can be very positive. Some students may give a score of 5 out of 5, but their text may not be as like positive, right? So they in this case, like the data may not be like directly compared. Even although they are like numerical values, we believe there's order in the data, right? Uh, Although there are a lot of text in data available, however, this kind of data are still largely like analyzed in research. Um, Oftentimes those text data are ignored, right? Our analysis often simply focus on numerical variables in our data set. Uh, the reason of that is although we are interested, we know like there are advantages in the text data collection. We should analyze it. The reason they are still underutilized because oftentimes they are more difficult to analyze than quantitative data. Okay. So this is an example data set I will use for demonstration in this workshop. So we have the student evaluation of teaching data. Um, we actually download the data from the Read My Professor's website. Uh, in this particular data set, we have about 38,000 evaluations on 1,000 professors. So the data are nested clearly, but when we analyze data, we ignore the nested structure. Okay. For each row of the data, we have the following variables. So first, we have the overall numerical rating of the teaching of the instructor. So that's the rating from 1 to 5. We also have the rating on how difficult the class was, and whether the students took the class for credit or not, whether the class was an online class or in-person class, and whether the textbook is used in the class or not, and also the grade the student received for this course. There are also two uh, text variables available. One is just a comment, a short comment. So the student can write a short comment about the teaching of the instructor. There's another variable, it's called a tag variable. So basically, they're like predefined like tags or the words or phrase to describe the instructor. You probably saw this before, like in some like online shopping website, like Amazon, right? It provide you some like predefined words you can select. See, this product is very good, uh, or the mailing is fast, something like that. So similar like this, maybe like a lot of homework, like a tough professor. So those kind of tags a student can choose when they evaluate the teaching of a professor or instructor. The data does not include the gender of the instructor, but we create a gender variable based on the text information. I will show you like later on how we create this variable. Okay. So this is one row of the data. You can see like here. Then we have the tags like respected, uh, accessible outside of class. And so this is like a paragraph of writing about the teaching. As I mentioned earlier, like text can convey like the sentiment of the writer, right? The sentiment of students, their feeling about the professor, their feeling about the course. It can also provide the context why they feel in this way, why they find the class is useful, or why they find the class was not useful. But at the same time, like text may reveal some information that you don't want to share, right? And for example, oftentimes uh, uh, you may like share some sensitive information in your text. It may reveal in the worst case, like you may share like your social security number, right? You may share like a driver license, your address, your home address. So that's probably the worst case. Sometimes you may also share some review some information like you don't want to review, like whether you are male or female, whether you are uh, your age, right? But a lot of people want to find like this kind of information. For example, shopping website, they want to find the information. They want to know you are male or female, so they can send the link and the products to you, right? And they want to find the age of you so that they can also market to you based on your age. Right? For example, in our teaching evaluation data, we don't have information on whether professor is male or female, right? In this case, but after we read like the teaching comments, we noticed that there are different words can be used to describe a male or female instructor. For example, a male instructor, they often say like he's great, he's a great professor, right? Or his class is very interesting. So in this case, the words he and his may indicate that the instructor is male, right? On the other hand, there's some other words used to describe women like instructor. For example, they use she, her, hers, words like this, right? So basically, what we did is we count how many these kind of words used for each instructor. For example, for the first instructor, like there like more than like 200 like words related to male, right? So in this case, uh, we may confidently believe like this is a male professor, right? And on the other hand, like we have like those words related to those professors, instructors, we may say like they are male professors. So based on this, um, we can kind of like assign gender to the to each instructor here. So now we have like the both numerical variables and text data, right? How can we combine them together to conduct our data analysis? So in our research, we saw like the easier way to make people or to let people utilize this method is we can specify this text data as a special variable, just like in any numerical variable or continuous categorical variable, or several like variables in SEM model, right? Uh, so we proposed this general SEM framework. So this is still a SEM model. It's a path diagram, but the difference is in this path diagram, we have a text variable. Okay, so those are the text information we extract from the teaching comments, right? Uh, so therefore, if we want to analyze the data, there's different ways to do it. One way is we directly include the text in this model. Another way is we can extract the information from this text. Then now we have a numerical variable, right? That's a representation of the text data. And then we can use that numerical variable in our SEM model, right? So that's become a kind of like a two-step method or two-stage method. If we use text as a variable in our SEM model, text can play different roles. For example, text could be an outcome variable in our SEM model. So in this case, we can investigate what kind of like factors or what kind of like uh, variables that relate to the text information related to how you read these comments. For example, we can say like whether grade, textbook use, or the difficulty of a class is related to whether you are read whether you will read positive or negative like comments about the teaching of an instructor, right? So in this case, text is a outcome variable. Text could be also the predictors, right? So we can use this, like for example, in like a daily diary like study, we may use the diaries of the participants to predict whether they have depression or not, right? Whether they have personality disorder or not. So in this case, the text can be used as a predictor, right? We can also model text and as a mediator, right? For example, we may study like we know uh, um, the reading being reduced like a stress, right? So in this case, we may look at what factors are related to like their writing, and then how this relate to like uh, stress like a reduction, right? So this could be like we can start like for different people, they may have different uh, they may have different habits or different ways to do to read. Some people like to read like every day. Some people don't like that. So we can look at the different characters of people related to like their reading and then related to like stress. Um, as I mentioned earlier, like one reason we don't utilize text as often as numerical data is because it's very hard to extract the information from it. Um, um, like in older days, what we often do is we code the data like manually. For example, you may have RAs to code the data based on the text. So you can ask RAs to read the text, or you read the text yourself to see like, okay, this text give us like a positive sentiment about something, or you can like say like what different aspects uh, are expressed in this text. So we can code the text into like numbers. But recent years there are many methods developed in the area of computer science that can be used to quantify text information much easier than before. For example, we can conduct a sentiment analysis. Sentiment analysis typically focus on positive, negative sentiment of a text. So in this case, we can assign a score to the text to see to tell people like whether this express positive sentiment or negative sentiment. This is particularly like widely used in online discussion. For example, in the online review of Amazon products, right? People may read like a review. If the review like express like positive information about the product or negative information about the product. So in this case, we can give a sentiment score. Okay. A sentiment score usually ranges from either -1 to +1 or 0 to 1. Smallest value means like is less positive. A larger value means more positive. Right? Uh, Another model methods or model we can use is called topic modeling. Topic modeling is more like uh, exploratory data analysis method. So we can find like what kind of topics are discussed in the review or in the comments, and again using like Amazon review. So they may focus on like how fast a product uh, is shipped. All they will focus on like the the price of the product, or they were like focus on like the uh, um, like other things of the product, like easy to use or difficult to use, things like that. So basically, using the topic modeling, we can identify those different topics. There are also better methods or newer methods based on neural network methods or based on deep learning methods that can even provide like better ways to quantify text information. I will show you some methods in this workshop. Uh, and recently, there are like large language models. The large language models can also be used to quantify our like data. I will also show you some methods in this regard. Okay. But however, like those methods may not like meet the needs of like uh, social science researchers or education researchers. The reason is like oftentimes those methods focus on how to quantify the information, how to extract the information. But as a researcher, oftentimes we are interested in how different variables are associated with each other, how the variables are interrelated, right? Like earlier I talked about a mediation model. We want to find if there's a mediator or not, right? So therefore, above and beyond the positive, negative sentiment, right? We also want to know like how those like sentiment relate to some other variables. For example, it could be related to like student outcomes, like students' performance in the class, right? Maybe like more positive lead to like uh, better like student outcomes, right? So therefore, rather than simply extract the information from the text, we actually want to look at how this information is extracted related to other things. So in this case, we can put this in a more general SEM framework. Um, I will talk about the several different ways to extract text information. Those methods are not developed or invented by us, so we are just using some existing methods. Once we extract the information using these methods, then we can use traditional statistical methods or statistical models to analyze the data. Some like popular methods included here, so like sentiment analysis can be like either based on dictionary-based sentiment analysis or based analysis, or now we can get the sentiment using like artificial intelligence or large language models, right? And then we can also extract the information use topic modeling, although like this may not be easy to use or interpret. We can also extract the information using some like newer methods like based on like word embedding or sentence embedding or text encoding. We can also extract the information from like large language models directly. For example, we can use ChatGPT to give us a sentiment score text. Next, I will talk about each methods one by one. The dictionary-based methods has been used for a while. It's old, but it can be very efficient depending on your purpose of data analysis. Okay, in the dictionary-based sentiment analysis method, each word is given a sentiment is given a sentiment score. For example, uh, this is the list of words and the score associated with it. For example, warning. Uh, it has like a negative sentiment with a score negative 0.5, right? Uh, but for this pristine, it actually has a positive sentiment with a score positive 1, right? So therefore, it shows like either positive or negative sentiment. It can also have a score 0. Okay. Uh, so basically, in the dictionary-based methods, we first build a dictionary with the words and the scores. And how to get the scores? The score is often provided by like a human being by the participants. For example, you can give list of words like on Amazon, I'm Turk, and then I ask people to rate like the positive and the negative sentiment of each word. And then you can aggregate the information together. You get the sentiment score for a given word. Okay, and most of those sentiment dictionary are developed in this way. So just um, ask people to read like a list of words. Okay. There are many different dictionaries available. This dictionary has more than like 10,000 words, and it has like different centimeter score ranging from -1 to +1. Okay. In illustration, I will use this like dictionary to calculate the centimeter score. Um, so these sentiment scores for are for individual words, right? And oftentimes we may have a paragraph of text, or we have like a sentence. So how to get the sentiment of text data? What we can do is we can first identify the sentiment words uh, in a text. Um, for example, like we may find like okay, uh, there are any different like words in a text. So, uh, so those are like sentiment words, right? If they are not sentiment words, we ignore that. So, for example, like some words may not appear in this list, right? So this viewed like words without any sentiment, right? So we identify those words, and then each word has a sentiment score, right? And then we can use a sum of the sentiment score of individual words. Uh, as the centimeter score of the overall text. Okay. And sometimes you can use average score, right? It depends on like how you want to use this. Uh, so the typical like sentiment-based methods also take into consideration of different modifiers in the text. For example, in some text, maybe like they will use words like if good maybe have a positive sentiment, right? But not good is like is opposite, right? Should give like a negative sentiment. So we may say like the shipping speed is good or it's not good, right? Right? So typically those methods can figure out this kind of like words. So can change the score from a positive to negative or negative to positive. There are maybe also some other like words can be used to like change like the sentiment of a word in a in a sentence. For example, we may say like um, the shipping speed is very fast, not just fast or very fast, extremely fast. So in this case, we also should give like a higher sentiment score, right? Based on like the extremely based on the very the words like this, right? So those called like modifiers. Uh, so if the for the modifiers, you may think about like you have weighted score, right? You can add weight to the centimeter scores when you get to the overall sentiment. So if the overall sentiment of a text is something we are interested in, oftentimes the dictionary-based methods can be actually very efficient. Um, um, for example, like for our teaching evaluation data, we have a little bit more than 38,000 teaching evaluation comments, right? And we may get the sentiment score using R package called sentiment R package. So that's based on the dictionary I just mentioned, right? So this code basically gives us like the sentiment. So what this method works is get the sentiment for each sentence in the text then take the average score of of those sentences, and then use that as the final sentiment score. For the teaching evaluation data, so that's the histogram of the sentiment score. Okay, yeah, you can see like overall the mean or the median is greater than 0. right? We may say like we may say it's a little bit more positive, okay, and neutral overall. There are also some other methods you can use here. Like we focus on the overall sentiment of the whole text. As we mentioned earlier, like the text may talk about several different things with it. In terms of teaching evaluation, like we found like some teaching comments about the personality of the instructor. This is not related to the teaching at all. And some other like comments about the difficulty of the homework and exams. Okay. Um, and some may be related to the effectiveness of the teaching, right? So in this case, within a same paragraph of the text, there may be different aspects um, discussed. Okay. So in this case, we can identify those aspects, and then we can get a sentiment score for each aspect. It's more like in fact analysis. We have several different factors. Each factor may have a factor score. Okay. This method is very similar with like previous like method, dictionary-based methods. We also need to build a dictionary for each aspect. Then we get the sentiment score. Right? Notice that this is for this kind of research, oftentimes because the sentiment, the aspects can be different for the different uh, domains. So therefore, you may need to like build a aspect-based sentiment method for each of your research question. Okay, so we did ours for the teaching evaluation. Uh, uh, Another method is called the topic modeling. Aspect-based methods basically, we predefine the aspects on different aspects of the text. The topic modeling can be used as a way to identify the different aspects from the text. So based on this, we may identify, okay, in this text, there are three different topics, so which means the text may discuss like the personality of the instructor, effectiveness of teaching, and the difficulty of the homework and exams, right? So those are the three like topics. How the topics are identified? The topics are identified based on the words used in the text, right? So if most of the words is about the um, personality of the instructor, so that might be a personality topic in the text. Okay. And from a data generation like perspective, it works like in this way. So for any given text, it can consist like different topics. You may think about, okay, how I'm going to like generate a new paragraph of text, or how I'm going to phrase new um, a new paragraph test. If you ask me to evaluate the instructor, I need to think about this instructor in different ways. Firstly, I believe like the my evaluation should be related to personality as well as effectiveness of teaching, right? So that's two aspects. I first determine that two aspects. Okay, so that's the aspects and the probability of each aspect. Okay. And once I decided like which aspect I'm going to write my comments about, for example, I decided like I will focus on the personality of the instructor, and then I'm going to select and organize words around like the personality of people, right? So not about the instructor. And in this case, I can pick the words. Each word has a probability to be picked, right? And for specific comments, the probability can be different, right? So if I read more about like personality, so the words related to personality is more likely to be used by me, right? If you read more about the difficulty of the exam, so those words will be used more often by you, right? So this basically gives the probability of each word is used in comment. Okay. Um, So, in topic models, we can use the topic probability as information we can extract from the text. So we think about, okay, there's different components in this text, okay, there's more or less of this of each of those topics or aspects. right? And then we can use that as like predictors or outcome variables. Okay. In general, for topic modeling, you can use the topic models package to do the data analysis. In this workshop, I won't focus on aspect-based methods and topic models because we have other methods we can use. I think it also works better. Uh, Another method to extract the information from text is to use something called text embedding or text encoding or called encoders. Uh, Text embedding is one way to kind of like represent your data as numerical information. So it's kind of like represent the data in a high dimensional space. Oftentimes maybe I have a dimension of 100, 200, or even 1000, or even more than like 1000 dimensions. Okay. You can think about like you can imagine there's like a space like out there, right? How you are going to put like those text into this space. Certainly, you want to put the text with a similar like meaning together. Right? Let's go to like individual words rather than like a sentence or the like text paragraphs or the documents. And for the individual words, if you want to put them in the space, certainly you want to put the words with the same meaning together. For example, you would put like dogs, dog and a cat together, rather than put like a dog and at least you should put those two words closer than the words like for example as a fruit, right? Apple, right? And the cats and dogs are much more closer than the words like apple in this space, right? So you may figure out a way to put every words in this space, right? Depending on their relationships. Okay. So therefore, the basic idea is to convert the text into numerical vectors. Okay, the vectors represent the position, and if you have two-dimensional vector, so which means you put like in a two-dimensional space, so then you have two values, x and y, right? So this gives the location of this like text, right? So these locations are determined based on the meaning and based on the semantic like relationships of the words, right? So after this embedding, we can change the text into numbers, right? And also like with this embedding, similar text will be closer they represent with this. So which means similar text will receive the similar scores, right? Um, and this method can also works very well for like multilingual text, right? So those are the different um, words for dog in different languages. So those words will also like appear together in this like space or in this representation. Here's an example. So in this example, we look at how to embed the words. Okay. Certainly, though, this is just an illustration purpose. It's not like exactly like the location of that. So notice that fish, wolf, and bear are grouped together because they are all animals, right? And salad and stew are grouped together because these are food. Fish can also be food, right? So therefore, fish is closer to here than like drinks here, right? So therefore, the representation here is basically tells like how those words are related to each other based on their meaning or based on their like it can based on many different things. So those features are actually learned by like by the different methods. Okay. So those representations are determined by complex models. And I'll briefly talk about this maybe later. And we can also directly embed like sentences together. So that's why like these methods are very useful. For example, those three sentences are grouped together. Okay. So this like is very useful in like a translation, language translation. So there's a like there is a like a large jump in the accuracy of like a translation in language models. The reason is because you can easily represent the locations of different language together, right? You can directly translate a sentence. In previous like without like those deep learning models, we translate the languages word by word, but now you can do that directly based on the sentences and even the paragraphs. There are different methods to do those like embeddings. For example, in the early like days, we use something called latent semantic analysis, and word to vector is actually still a very widely used method. So it's changing word to vectors. Now the neural methods based on like recurrent neural network, and particular transformers is the uh, primary method used for embedding now. The transformer can take uh, take into consideration of interrelationship of words within the context, within a sentence or within a paragraph. So it's much more efficient or powerful to embed the text information. This is a list of some like embedding methods and encoders. Those methods are basically those like methods are trained on a lot of data and then determine like the vector scores for after embedding. Okay, and for example, like this method can embed like data into um, sets like this. So it's more than 3,000 like dimensions of data. Okay. Um, so this is called um, uniform sentence encoders. So universal sentence encoders. So those are developed by Google. They encode like a text into like 512 like dimensions. Okay. Another way to think about those like embedding methods or encoders, you can think about them in terms of fact analysis. We know like in fact analysis, we can analyze um, the numerical data and then represent the numerical variables, represent the observed variables as latent scores, right? Latent fact scores in a fact space, right? But here you can think about we fact analysis text, and then we put like the text positions in this like a semantic like space or in this like language space maybe. So this is an example we use the universal sentence encoder developed at Google. So this basically will encode like text into 512 dimensions. Okay, so here I basically embed like several words, 5 words here. Okay, notice for each word for cat, it have it gives you like a 512 scores. So this gives you the first 5 scores. But basically they have like scores like this, right? Um, More than 500 of them. And so therefore, for these 5 words, after embedding, we will get a matrix. The matrix will have uh, 5 rows, each row for each word. Then 512 columns. Each column is an embedded score for that dimension, right? After I get the scores, certainly I cannot easily visualize this like using any computer. But what I did is I calculated the correlation of the embedded vectors, right? As I mentioned earlier, if the 2 words are similar, they should receive like similar scores, which means they should give you like a large correlation if I want to calculate the correlation, right? So this is the correlation matrix. You can see like cat and dogs, cat and dog. So the 2 words has a correlation 0.814 based on the 512 vector values. Right? Um, and at the same time, you notice the cat has a smaller correlation with apple than dog, right? So which means certainly because they are more similar, right? I also put like 2 other words. One is like animals and fruit, right? So this is more like not like individual animals anymore. So it's kind of like a category of like words, right? So we notice that this animal has a word has a higher correlation with cat and dog than the correlation with apple, right? So which means these three words should be grouped together closely like in the space than like apple and animals. Similarly, like apple and fruits, they have a higher correlation, right? This correlation larger than the correlation between fruits and this cat and dog, right? So therefore, at least like based on this very simple example, it makes sense, right? It does like capture the association of the words. Right? Uh, Here's another like example. Notice the text embedding can include the biases, like because like those embedding methods are trained on the data. So if your data has shows bias, this embedding will like inherit these biases in the trained data. Okay. For example, here I'm trying to like um, embed like those words, right? Male, female, and engineer, and several other like professions. So you notice that so this again I use correlation because it's easier for me to show this. Okay. Um. You notice that like in this example, if you look at the group like word male, right? It has a correlation with engineer and construction worker with this correlation, right? Uh, on the other hand, with like nurse and school teacher, there is a like a small correlation, because like there's this kind of like a stereotype like in the society, right? Usually like engineer and construction workers are male, nurse and school teachers, teachers are female, right? So this actually represent this kind of like a stereotype type, right? So which means certainly this is not correct. This represents some kind of bias, right? But I want to point out is although this kind of embedding learn from the data, but they may not truly like reflects like they may not like reduce bias. They actually will inherit and sometimes even like amplify this kind of stereotype or the bias. So this is use the universal sentence encoders. You can also use the other like a large language model to encode your data. For example, you can use ChatGPT. I will show you how to do that later. And you can use the Gemini of Google, and you can use also other like large language models. How to connect those like embedding methods with like sentiment analysis, right? Earlier we talked about sentiment analysis based on dictionary. This is very easy to understand because each word has a sentiment score, and then we need to combine these sentiment scores together. We get the overall sentiment. Uh, yeah, with the embedding, there are many different ways we can actually get the sentiment. One way is we can train like a supervised model. So, for example, we may obtain like a text as a label of the sentiment. So, for example, we get this text, we ask people to read the text to give a score about the sentiment, right? So in this case, input is a text, output is the sentiment, right? And then we need to build a relationship between that, right? We cannot directly build the relationship between text and the sentiment, but what we can do is we can further embed those texts. So for example, we can use um, universal like sentence encoder. We can have a 512 dimension of vectors here. So this could be the input of a deep learning model, a neural network model, right? And then we build this relationship between these input vectors and the sentiment. Okay. So therefore, even for like the deep learning models, we still need new numerical information, right? We cannot directly like analyze text. We have to convert the text into certain kind of like numerical values. Okay. And then we can build the model like this, right? So when we have a new text, what we can do is we can first encode or embed the text into these numerical values, and then we run pass through this model, and then we get predicted text sentiment score, right? So that's a sentiment based on um, based on deep learning methods based on the text encoding. Okay. Uh, in in the literature, there's several different methods or ways to do the sentiment analysis. And for example, in R, there is an R package called the sentiment AI package. What this sentiment AI package does is it builds like a model between these encoded vectors, right? So we have, you can think about we have 500 like 12 x1, x2 scores, right? And then I can do a regression analysis, right? So regression analysis outcome is what, right? So I use those uh, amount of information to predict the centimeter score y, right? But to do that, the first thing is we need to look at the relationship. We need to get the regression coefficients for this beta 1, beta 2, right? To get those regression slopes, we can collect data. So we can collect the text data. We can get the sentiment of the text. And then we build this regression model, right? So we have new information. And then we can use the new text to give a predicted score for the sentiment y, right? So that's this how this like package works. Okay. Uh, but this package does not only include the regression model, it also include like a tree model. So you think you can build like a uh, tree between those predicted those vectors and the outcome variable. The advantage of the tree method is it can take into like a nonlinear relationship between this x and y, right? This is how we can get the centimeter score using this centimeter AI package. Okay. Um, because like the universal sentence encoder is done in like using Python packages or Python software. It's not directly conducted in R. So therefore, we need to like install Python our computer to use this package. Right? The original like instructions to install like a sentiment AI package you can fail easily. So to make like the installation of the this easier, as well as like installation of our TextSEM package. So we actually wrote like function to install the necessary like Python packages onto your computer and then use it. Okay. After you install our TextSEM package, I will show you how to do that later, right? You can uh, install like the necessary packages using this function. Okay. And then each time after you load the TextSEM package in the future, you only need to install the Python like libraries once or Python packages once, right? But before you use it, you still need to initialize your model to use the R package. Okay. So basically, after those two steps, you should be able to use the sentiment AI package to get the sentiment score for your text. So in our case, for the teaching evaluation data, so this is the comments. So the function we use is called the sentiment underscore score. Okay. So this function is a part of the sentiment AI package. Okay, it's not a part of our package. Okay. Uh, this is the sentiment score from the sentiment AI package. Okay. Remember this method is based on like text embedding. So it's first embed your text and then using a prediction model to get the sentiment score. Okay. Notice the distribution is a slightly different, not slightly different, it's very different from the distribution we saw before using the uh, dictionary-based method. Using a dictionary-based method, remember, like the scores are pretty normally distributed, right? But this is clear bimodal distribution, right? There's distribution at the a negative sentiment distribution as a positive sentiment. Okay. We can compare those two methods. The correlation between the sentiments uh, for the decrement-based method and the embedding-based method, I just call it, also sentiment AI, is about zero point 0.7. It's pretty large correlation. Okay. So that's the this is the scatter plot of the okay, and this shows like a slightly nonlinear relationship. Okay. I don't know the reason why it looks like this, but just two different methods give different like sentiment score estimates. It's expected they are different. Okay, but I cannot explain this particular pattern. Okay, the sentiment AI package is based on very simple model. Certainly, you can build like more complex models, particularly may work even better than the uh, sentiment AI package. Uh, we can also get the sentiment score based on like large language models. For example, one is we can use like ChatGPT, right? And in the ChatGPT, we can directly ask the ChatGPT to output a sentiment score. For example, this is an example. This is our teaching evaluation text data. This is the instruction uh, to tell what the ChatGPT should do. So basically, I asked to give me a score between 0 and 1. 0 means negative, 1 means very positive, zero point 0.5 is neutral. And I also asked it to give me a score only. Just give me a score, nothing else. Okay. It's called like text completion. Um, you may guess like what is the centimeter score for this text is. But if you use like ChatGPT, for example, this is what I use. So after I give this instruction, give the data, give me a score point 0.9. Okay. So point 0.9 is quite positive because the largest score is 1, right? If you have more data, if you only have very few, you can do this like manually, right? And here in our case, we have more than 38,000 um, text comments. So in our TextSEM package, we also install the OpenAI package to use to conduct sentiment analysis directly using ChatGPT. So this basically provide API. API is called like a application programming interface. So which means give you a programming way to use uh, ChatGPT or OpenAI. Okay, but to use that you need an API key. You can get a API key after you register for account on ChatGPT or OpenAI. This is the code we use like to get the sentiment score based on the ChatGPT. So first we import the Python package OpenAI. Then we so like this is a loop. So we loop through all the text comments. Okay. Then our response basically is check completion. We completed this sentence. Okay. And you can use different models. So we use a very low expensive model because we have a lot of text data. Then you can tell what ChatGPT to do. Okay. So you don't need to change much of this. Just those are instructions. You can freeze based on your own problem or your own research question. So we save the GPT score for each comments. Okay. So that's basically what the um, code does. Okay. So this gives us like the distribution of the sentiment score using ChatGPT. Uh, so this leads similar to the score we obtained using sentiment AI. But notice that uh, it for most of like the score that give you like specific categories. For example, this is seems to be like a point, point one, 0.15. 0.2, things like that, right? Score, which means the scores has less like distinguished like categories. Okay, and it also gives you a bimodal distribution. Okay, the correlation between the centimeter score based on ChatGPT with the dictionary-based method is about uh, 0.68, but with the centimeter AI method is about 0.83 because both this method and this method kind of based on like embedding, based on the word embedding or text embedding method. Uh, this is the scatter plot between like each of the two methods. Uh, so this is between like GPT and centimeter AI. So, but this does not show much like pattern maybe because they overlap with each other. But remember, the correlation here is about 0.83. Okay, GPT and the dictionary-based methods. So the correlation here is only 0.68, right? Uh, and this one is like zero point 0.7 correlation. Um, so now we have like information we extracted from the text, and then we can fit the SEM model. I will skip this, but basically we include like the text with the SEM with the SEM model. Okay. To estimate the model, I already mentioned this is previous. So we can either use a one-stage method or two-stage method. A two-stage method means like we first use the different methods to extract the information from the text. Then we analyze the data with the SEM model as normal, as usual. So because now the text information are numerical information. Right? The advantage of this method is it's very easy to use and it's intuitive, right? And once you extract the text information, you can use it forever. You can use it in any other models, right? The disadvantage of this method is typically when you use a two-stage method, you will lose like statistics efficiency. For example, you may selectively lose your power. Um, and we can also use one-stage methods. One-stage method certainly is advantage is in general is more efficient. Okay, not always this case, but in general that's the case. But the issue is it's often hard to estimate. And oftentimes, like the one-stage method using based on the deep learning does not provide ways to do statistical inference. For example, it cannot test the significance of the mediation effects. It cannot give you a p-value for a given path coefficient. Okay. Uh, Limbo actually developed like a method in her dissertation as kind of like one-stage method. But in this workshop, we'll focus on the two-stage methods um, for data analysis. Uh, we also did like some comparison. Mainly Limbo did this. So Limbo like basically fit like the different models using one stage and two-stage method. For example, this can based on one stage method to use BERT. Um, BERT is a very widely used like embedding method. Using BERT to embed the data and then fit regression, fit lasso methods. Then look at the mean square error. Mean square error, small is better. Okay, R square larger means better. Okay. Then also use like this can be kind of like can be considered as like a uh, one stage method. So using like embedding method and then use a deep learning model to analyze the data. Okay. Uh, if we simply compare this, we notice that like we want to look at the test mean square error and the test R square, so larger is better. Okay. You notice that like the if you compare the two methods, so this is the best method among like a group of methods we tested using two-stage method. Okay, these two methods in one-stage method. We notice that okay, certainly use one-stage method give you smaller error, give you a larger R squared, right? But we also notice the difference is not huge, right? So which means like two-stage method may still work in many of the situations, but at the same time it has advantages of easy to use. Um, so therefore, like in the next, I will show you some examples, and in these examples, we actually use a two-stage method. We first extract the text information and then fit SEM. So our text SEM package actually combines the two stages together. So you can just like supply your model and your data, and then we can give you the parameter estimate directly. However, once you embed the data or once you extract your text information, you can use any other SEM software. For example, you could use like OpenMX, you can use M plus or EQS. It doesn't matter which software you use. So next, I will give you several examples. Uh, Maybe we'll take like a 5 minutes break. Uh, we can come back at 1:35 so people can have some water. I can also have some water.
Okay, so Jiefeng has a question on topic modeling.
Uh-huh. Let me see. Uh, Determine like the best number of topics. Um, there's some like test statistics you can use to determine the number of topics. And in the topic models package, oftentimes they use complexity as a measure of like however where a model fit. So which means you can fit the topic models with different number of topics. Oftentimes start with one then two, three, four, five. And then you can plot the complexities, choose a model with the smallest complexity as your final model. That give you the based on the number of topics. But just like the way you determine the number of factors in exploratory factor analysis, um, these methods may work very well or may not work very well. Okay. Um, Oftentimes like you should combine like those statistics with your like background knowledge about this text, so determine like the number of topics. And when you once you determine the number of topics, or once you set the number of topics, you know you can output the topics and the associated like words. Uh, and based on those words like related to each topics, and you may like combine some topics or split some topics to make the topics more meaningful. Because eventually, like this method um, is like a kind of like exploring method. You want to explore how many topics there is not like a confirmatory data analysis method. So therefore, it can involve a lot of like uh, subjective decision making process. Okay, we'll come back maybe 1:40 to give you some time so you can use restroom or take a break or stretch out. Okay. Okay, let's continue. Next, I will show you some examples on how to combine the text information we extract, the information we extracted from the text and with SEM. Particularly focus on those five examples. The first three examples are based on a sentiment analysis, kind of like a sentiment analysis. We use a different ways to get the sentiment score for the text. Then next example, one is we directly use the uh, in, encoders or the embedded vectors in our data analysis. Last model, I will show you an example with more than one text variable. Let's look at a very simple example here. So we want to look at the mediation model. Uh, we have found like the difficulty of a class is related to the rating uh, of the instructor. So there's a negative association, which means if a class is more difficult, the rating score of the instructor is lower. So certainly it's intuitive, right? But I want to know like whether comments can serve as a mediator between that. Okay. So the idea here is like whether class is more difficult or not will influence how you are going to read the comments. So for example, more difficult, maybe you read like less positive um, comments, and less positive comments then lead to like lower score for ratings, right? So therefore, the path here should be negative, and this path should be positive, right? And then comments would play uh, a mediation role here. Okay. Uh, and if the comments is continuous, certainly we can directly fit the model using any like the SEM software, right? But here, after we extract the sentiment of these comments, so this also become a regular SEM model, right? So using like the TextSEM package, we can specify the model, just like what we did for like Lavan package. So this package, our package is also based on Lavan. So we use Lavan as the part in the second stage for SEM model. Okay. So therefore, you can specify the model using Lavan method or the way of Lavan to specify the model. In this example, we specify median model using these two equations. So the rating kind of regress on difficulty as well as comments. So I have a coefficient B. So that's basically coefficient here, right? So rating, comments, and difficulty, and then comments on difficulty. And the comments regress on difficulty here. And we are interested in the mediation effects. So therefore, I also define new parameter called AB. AB equal to A times B. Okay. So this also have a Lavan define the indirect effect, also mediation effect. Okay. To estimate the model, we have developed this SEM sentiment function. In this SEM sentiment function, we need to specify several things. One thing is we need to specify our model. Okay, so the model basically is the model we just defined here. Right? It can be any SEM model. And then we need to provide the data frame. So that's our data set. Uh, the data set in our case is called Professor 1000. So that's 1000 professors information. Notice that when you use our R package, you don't have to get the sentiment score first. Okay, so we streamline this process, the two-stage process. What you only need to do is you need only to tell the name of your text variable. So basically means the comments is the name of a variable in this data set. Okay, so remember we have like maybe ID, we have difficulty, and we have rating, um, and then we have comments. So the comments is text. Okay, they are not numerical values yet. They're just text information. So you all need to do what you all need to do is just tell okay, comments is a text variable. Okay, and then this function will take care of both steps. First step, it will estimate the sentiment. Next step, it will estimate the SEM model. Okay, by default, this function using the dictionary-based sentiment analysis method. Okay, to distinguish the text data as well as the sentiment score, we actually add a new variable in your data set. So which means we add this column as the end of your data set. It's called the comments sentiment. So therefore, like in the future, if you need to redo the data analysis, you don't need to do the sentiment analysis anymore. You can directly use the sentiment score. By running the data analysis, we can get the results look like this. Okay, so if you have used Lavan, so it's very familiar output. Uh, the most important part of this analysis is here. So we have the coefficient. So the rating on difficulty, so we have a parameter estimates. Um, so this is the direct effect, right? Direct effect of difficulty of the class on rating. Then this is called a comments sentiment score because it's too long. It is short the name into this. So it's comments sentiment. Then you have uh, the label of the parameter B and A here. Notice that it also provides you standard error z test, z-score, and p-value. So therefore, you can do the statistical inference. As I mentioned at the beginning, when you use the two-stage methods, uh, those inference methods may not be as accurate as using one stage, but in majority of the case, the difference can be ignored. We also have a defined parameter, A times B. So that's the mediation effects is negative um, 0.196 and is significant. So which means there is actually exists a mediation effect here. And if we put the parameters into the path diagram, you can draw the path diagram directly within R. Okay? So the difficulty is the input. The numerical reading is the output, right? And so this comment sentiment is a sentiment score from this comment variable, right? How do we read this? So notice the difficulty is negatively related to the sentiment score. So which means if the class is more difficult, the sentiment of the text will be less positive. Okay, this means more negative, more negative. So there is a negative relationship as we expect uh, as beginning, right? Then the sentiment score is related to rating. So which means if the sentiment is more positive, you will get a higher rating score, right? If it's less positive, you will get a lower rating score, right? So this also positive, there is a positive relationship, right? The direct effect is negative uh, 0.32, right? So the total effects, as we know, the total effects from difficulty to rating is the direct effect here plus the indirect effect. Remember, our indirect effect is negative 1.96. So this is negative 1.96. So that's the indirect effect. So the total effects, we add them together, is about negative 0.516, right? Uh, what we are interested in, like, say, like, after adding this potential mediator, how much relationship in between is explained by the mediator, right? So here I define a very simple, like, effect size measure to just measure this. So I define this effect size is as negative 196, so the indirect effects over total effects. Okay. So it's around like little bit less than 20%, maybe 19%. So which means the 19% of the relationship between difficulty and reading is explained by the centimeter score. All you can think about is explained by the text, by the comments. Okay. We can also use other methods to do the data analysis. For example, we can get the sentiment based on the sentiment AI package. So this is based on like further embed the data into vectors and then feed it like a random forest model or feed it like a regression model to get the sentiment score. Okay, the model specification is exactly the same, right? Because the same model. The only thing that changes is we change the methods for data analysis. So I changed the method to be sentiment AI. Okay. So now we got the output. The output look like this. So the direct effect is negative 0.225, right? The indirect effects can be calculated by A times B here. So that's negative 0.293. Okay. Uh, some of the coefficients, so some of the estimates here cannot be directly compared from the two model. The reason is because the sentiment score are on different scales, right? For sentiment AI, I think it's from 0 to 1. For the dictionary-based methods, there's no like restriction on the total centimeter score. So therefore, we cannot directly compare that. But what we can compare is we can compare the proportion of mediation effect, right? So in this case, would be the proportion of this over negative 0.16, right? So it would also be like a negative zero point 0.3 almost plus negative 0.225. Okay, so it's about the same. So notice that here we have about 60%, right? 60% of like effect is explained by the text, by the sentiment of the text. Next we can use like another method. So we get the sentiment score based on the ChatGPT. Right? Remember that earlier I've showed you that one simple example how we can use the ChatGPT to get the sentiment score, right? So I basically using the API to repeat the procedure for every uh, comments, and then I saved like the sentiment score. Okay. It will take a lot of time to run this analysis. Also, like ChatGPT may not be 100% accurate. Sometimes the output may not be a numerical value, so you need to fix that first. So what I did is after I run like this sentiment analysis using ChatGPT, then I check like the scores that look at the all this, not look at all the scores, basically uh, tabulate all the scores, and then I found like for about the three or four text of three or four comments, the sentiment score are not correct. Then I redid like the analysis, kind of like using like ChatGPT individually, and then I get the sentiment score. After that, I save all the centimeter scores into a file so I can use like in the future. Right? In this case, I don't have to rerun the centimeter analysis if I need to fit a different model. Right? Then I add the centimeter score, GPT centimeter score into my original data set. So this is my original data set. It's a new variable created. Okay. Then I run my model, the same model, but now like uh, instead of doing the comments directly, I use GPT score directly. You can also run this like two stages at one stage, but as I mentioned earlier, uh, you may encounter errors when you do this. The reason is because for the ChatGPT part, we cannot control. That's kind of like a third party, like application. It's also like a remote server. Okay. So the best practice is just save the scores and then use it later. Now, once we get the score in the second stage, we specify our um, median model. Then we run the analysis directly use the Lavin SEM function. Okay. They will specify the model, specify the data. In this case, we don't have a text variable anymore in this model, right? Because the text variable was already converted into the numerical scores, numerical values. Okay. Then now we get our parameter estimates. Uh, so this is direct effect, and then this together will give us the indirect effect. So the indirect effect is negative 387. And remember the total effect is again like negative 1, negative 516, right? So we can calculate the proportion uh, of the effects explained by the mediator, by the text. Okay. Uh, then there may be another method we can use to do like this data analysis. So previously, like when we use all the methods, we only get one score. Um, that's the sentiment score, right? We don't necessarily just get a sentiment, right? Because for example, after embedding, we convert the text information to the numerical information. Then those uh, numerical information is converted into a single value, right? But we don't have to convert those uh, like amount of variables into a single variable called the sentiment score, right? It may have some other information, like in addition to the sentiment information, it may have some other emotion information in the data in the vectors, right? So one way to analyze data is we just use the raw embedded vectors as potential mediators, right? Then we can build a model. In our model, the model will become things like this. So here, rather than using like this comments here, I can use like vector 1, vector 2, depending on how many like embedded dimensions. Suppose I use like a universe, so sentence encoder. So I have a total of 512 variables. So those are numeric values. So I can use all of them as mediators. I connect them together. So I have more than 500 potential mediators, right? They can fit this model. So this model basically includes multiple regression models, the rating on difficulty, and 512 V's. They have individual regression model, each difficulty to V. They have 512 individual simple regression model, right? So that's represents the median model. And they have a coefficient. This could be A1, B1, A2, B2, and so on, so forth. So I have like A 512, then B 512, right? Uh,
Oh, there's a
notice,
question in the chat.
okay. Notice that using these individual vectors may not very meaningful. So, but what we can do is we can get all of those midi mediation effects together. So this is overall mediation effects. But now we can like utilize more information. Okay, let me take a look at the question. Uh, First of all, for the question whether we assume the coefficient of difficulty is 1, no. The coefficient for the difficulty is estimated. So just like so that's a coefficient. It's just like in SEM model specification, in the Laval model specification, uh, happened here. Uh, so in this model specification, if you don't put anything here, it assumed it's a free parameter, so it will estimate it. So therefore, like in the output, not sure what happened to this man. In the output here, so the coefficient is negative 0.322. Um, there's another question. Yeah, I think it's a similar question. Yeah. Okay. Uh, so in total, we have like a lot of coefficients, right? You could also like conduct the analysis using SEM package, but in general, like when you have like several hundred variables, many SEM packages can be um, may not work like correctly, or it will take a lot of time to do the calculation. And in my case, because I have like a simple median model, right? So I just simply calculated the analysis using regression models. So what I did is I first embed my data using this embed text message package. So after embedding, I get the text embedding with in total I have remember I have 38,000 rows plus times 512 columns. So that's my embedded data, right? Doing this embedding will take a little bit more time, take a little bit of time. So therefore, what I did is I save the embedding on my computer so I can use like in the future. So this is the embedding procedure. Okay. And with that, I can do my model estimation. First, I estimate this model. So this is a multiple regression model with a difficulty predictor, and then 512 other predictors as encoded vectors. And then my model, in my second model, so this is 512 individual regression models. So which means for each this j equal to 1, I will fit a regression model. I get 1 alpha. So in total, I have 512 pairs of alpha and beta. Right. Then I add them together. It will give me the um, overall mitigation effect. Okay. So these are code to the data analysis. Okay. So this first model regression model give me all the betas. And the second model is um, I use like a loop to run all the regression model to give me A's. And then I calculate the overall mitigation effect as them together. So the standard error of these mitigation effects can also be calculated using this. So use the standard error of alpha and beta. So it's based on the delta method. I get the standard error. Based on this analysis, the mitigation effect is negative 0.327. As I mentioned earlier, if you look at the individual effects, may not be very like informative, because like we have like all those A's, all those B's, and if we multiply them together, we have AB. Uh, so that's why we don't look at the individual effects. Rather, we look at the overall effects. Okay. Uh, As I mentioned earlier, doing like all those include all those embedded vectors could be tedious and difficult to do. And in the TextSEM package, we we actually implement a slightly different method. So in our methods, what we do is once you have the embedded vectors, for example, you may have 512 vectors. Then we do a dimension reduction. Right? For example, you can use principal component analysis, or you can use the single value decomposition. Can reduce the dimension from 512 to 8, right? So if you do this, it will be much easier to do your data analysis, right? So now, in my median model in between y, so I only have 8 m's, so it's m1 to m8, right? So it's rather easy to handle, right? So therefore, if you do want to choose using this one-step method, and you don't want to do the embedding yourself, you can still use our package. So the package will do uh, a text embedding, dimension reduction, then estimate the model. Okay. The embedding procedure can have issues because again, the embedding procedure is a third party application is not developed by us. Okay, but we have found it works pretty reliable for most of the case. Okay. So in the following example, what we did is we first embedded the data into 384 dimensions vectors. We use some embedding methods other than um, universal uh, sentence encoder, and then we reduce this to 5 dimensions. Okay. Um, you need to decide how many dimensions you want to choose. So this basically become a procedure will select the number of factors in effect analysis. Okay. You can use a script plot, for example. You can use other methods to determine this dimension. Okay. But in the function, the default value is 5. So if you don't specify how many dimensions you want to use, you just use 5. Therefore, to do the data analysis, what you can do is you can specify the model directly like this. So this is still a model, right? This is your data. This is not required. So which means you don't need to do this. So when you specify this, you do the estimation, it will automatically embed the data. But this embedding is oftentimes takes some time. Uh, doing the embedding is the same no matter what kind of model you are using. Right? So in general, we recommend you to embed your data first, and after that, to do your data analysis. So basically, what we did here is we embedded the text comments into this. Right? Then next we use this function. Notice what this function does is you still specify the text variable using its name. But what it does is it first try to find like this. If they find this, then they will do the data analysis using this uh, already embedded data, right? If they cannot find it, then it will do embedding automatically for you. Okay. Uh, if we do the data analysis, we can find the median effect is negative 0.136. Okay. Now let's do a comparison among those different methods. So I use 5 different ways to do the data analysis, remember? And the first I use a dictionary based method. I got the mediation effect is um, negative 0.196. Okay. And although some parameters cannot be estimated, but we know the total mediation effects can be estimated. So it's 5 can be compared negative uh, 516. I hope this is correct. It should be close. Uh, so we compare this as a proportion of the total effect. We see how much. the median effect, the effects can be explained by the text. Okay, so I use dictionary-based method. It explains about close to 40% of the effect from difficulty to reading score. Okay, and when I use AI based sentiment analysis, so it's explained about close to 60% of the mediation, not the mediation, total effect. Okay. So this is used like the uh, all the embeddings. Remember, like uh, 512 vectors. So next explain a little bit more than um, 63% of the variance. Okay, and we can also use ChatGPT to get the sentiment, right? So this is sentiment score method. This is sentiment score method. This is sentiment score method, right? If I use ChatGPT, it actually explains more than 75% of the total effect. Okay. Um, but so that's basically like the last method I showed you. We first embed the data and then using single value decomposition to reduce the dimension to be 5. Okay. So this is the dimension reduction method. So when we use the dimension reduction method, we have mitigation effects this. So this is the smallest. Let's explain the uh, least in least information is the total mitigation effects. Okay. What does this mean? This means like the information in text can explain up to 76.6% of the total effect among the among all the methods. So, which means like initially our question is we already see like okay, the difficulty of the class is negatively related to the numerical rating, right? But we want to like explain why that's the case, why that's the case. Okay, so we found that we can use the information in the text in the comments, right? So the information in the comments can actually explain a lot of info relationship between the difficulty of the class and the rating of the class, right? Certainly, you may argue like it's still very difficult to explain, right? Explain why texts are related to that, right? But at least like this is the mechanism maybe as a way like to explain how people phrase their comments or how people like read their comments. This can be viewed as a reasoning process, right? And if we further look at the coefficients A and B, we notice that the class difficulty is associated with the negative source, right? No, or the negative sentiments of the text. Then it leads to lower ratings in um, in this example. Uh, so far I only use the like quite like a simple example. We only have one text variable. And also we only have three variables in that model. So that's a mediation model. But we can use more complex models. Remember uh, in our data set, we have two text variables. One is comments, another text. And both and text and comments reflects the teaching evaluation, right? And we also have a numerical values like rating score. So previously we use rating as the outcome. However, the rating is also a measure of teaching effectiveness or teaching like performance, right? So from like a fact analysis perspective, we have talked about this earlier, right? We may not be able to measure teaching directly, but we can collect data on numerical ratings of it. We can also ask people to write about the teaching performance. And then we should combine those three variables together to create something called teaching evaluation or teaching performance, right? We would expect that this would work better. Why is it work better? Because we have more information, not just from like a single variable. And another advantage of this is, as we know, like when we use fact models, we can also handle measurement errors, right? So those comments or tags may not be accurately reflect the teaching performance. So we want to remove the measurement error parts, right? So therefore, we create like a measurement-free teaching evaluation or teaching performance factor, right? And then we can look at how other factors are related to the teaching performance, whether require whether the use of a textbook related to the teaching performance, whether how the difficulty of the class related to the um, teaching performance. Notice now I use three predictors, so which means when I look at the relationship between one and the teaching performance, I can also control other variables, like as in multiple regression analysis. Right? So now I have a much more complex model, and this model involves a latent variable, right? If you remember, this model is also called a mimic model, right? And in this mimic model, we can also look at the mitigation effect from difficulty to rating, but now through this teaching performance factor. So how to specify the model? A specify the model is actually uh, very straightforward. So we need to define the teaching performance factor. So this part. So the teaching is measured by two text variable and one rating, numerical rating. So I also add the label B here because I'm interested in A times B parameter. And now I define the multi-cause like model. So um, this is the multiple regression model. Okay. Then to do the data analysis, I still use the sentiment analysis method because it's much faster to show uh, how the analysis works. Okay. So I specify the model on my data. Now I specify vector of text variables rather than just comments. I use comments and tags. Now I have two. So this is the output. Notice that in the output, I created two new variables. One is called text sentiment. Another is called comments sentiment. Okay. So those are sentiment scores based on the dictionary-based method. Okay. And then this is the numerical rating score. Okay. Together forms this teaching performance factor. And they have a regression relationship. How this factor related to the three variables here. So whether it's open book or not, and this gender and difficulty. Okay. And if you look at here, all three variables are actually significant. Right? In this kind of models, we often focus on is interpretation of here. Right? So basically what this means is if the class use a textbook uh, and then the instructor will have higher ratings on their teaching performance. Okay. It may make sense because when you use a textbook, it's easier for students to follow the class, right? So it's contributed uh, to the final evaluation. Then we look at the gender. So this estimate is also significant. Uh, it's highly significant, certainly maybe because of the sample size, right? The effect size itself may not be large, right? But effect size is another issue we don't want to consider here. Okay. But gender has a positive effects. So this means because zero is I think zero is female, one is male. So this means like on average, for male professors or male instructors, they received a higher rating on their teaching performance. Okay. The difficult variable is negative. Again, if the class is more difficult, the rating will be lower. Okay. At least the direction here makes sense. Uh, the mitigation effect here is point 522. This one cannot be compared with the previous like data analysis because this is a totally different effect. Okay. Uh, in the previous slides, I basically showed you how to use R to do the data analysis, right? And I also shared this markdown file with you. And in this markdown file, I have all the code I used uh, in this like workshop. I probably won't have time to go through the code, but let's see. If I have time, I will briefly talk about the code. Okay. But in addition to the R package, we also have an online app. This online app can be used to conduct text analysis directly online within a web browser. Okay, so uh, it's called BigSEM. So you need to register to use this. You probably cannot do this because we need to manually approve your registration. The reason we require registration is because you may need to upload your data. So it's a one way to protect the privacy of your data. It's an online app with a graphical interface. Okay. So we put this on server. So if you are interested in host your own like server for doing this, you can talk with us too. So basically, all the analysis we I showed can be conducted online too. So once like you log into the website, it has something like has an interface like this. Okay, so it's more like a GitHub, but just like a different way to organize the things. To the conduct the data analysis, you can draw a path diagram. So you just click this path diagram button here. It will open a window look like this. Oh, this SCM text maybe. So let me show you an example here. To do median analysis, and we need to specify this path diagram. Okay. And you can draw the path diagram directly using this button here. And more importantly, we need to specify the software we need to use. So for example, you can select TextSEM and then select the data set. If you want to calculate the new parameter, you just use this. Slightly different from the one, if you use two equal signs, it means the define the definition of a new parameter here. Uh, so once you have the diagram, you select your data set, you specify like the other information. You can click this run button to get like the data analysis. Um, it will take a little bit of time. So I only use a subset of data here, but 1,000 I think comments for this 1,000 comments can be very fast. So after you run the data analysis, just click on the results. So that's different. There's different blocks of results. So first give you some descriptive statistics about your data. Minimum, maximum, particular skewness kurtosis um, for like for normality test. Okay. Then the next part of output will be the same as uh, I showed you in my slides. So because it's the same as our output. So we have the um, A/B parameter estimates. So we have this is the direct effects and the indirect effects. The values are slightly different. The reason is, so this is based on 500 comments. In our original data set, we have 38. 100,000 text. As I mentioned earlier, sometimes it may be like more useful if you use a multiple stage methods. First, for example, first you can get a centimeter score, and then you can do the following data analysis. This app also makes the use of that easy. So uh, what we did like in this app, we provided some like simple routines so you can direct the centimeter scores. Uh, so once you upload your data, notice that you can get a list of all your files, right? And for your data set, there's a button called the analysis button. So that's a subset of the data. If you click on this, this shows you the um, basic information about your data set. Just lists the first few rows of your data, right? And if your data are good, just click on this button. Uh, then we provide those different menus so you can do some analysis. For example, if you want to get the text sentiment, right? So you just click text sentiment. Then you select the variables you want to get the sentiment from. You can have more than one variable. So if you want to have comments and text, I want to get the sentiment based on the dictionary-based method. Okay, and click here. You can only use one. Uh, It should work for two, but uh, using like just one centimeter columns. So what it does is it create like uh, column with a name sentiment. Maybe we should change this to be like a common sentiment. Then it's also give you some basic information, give you like the basic information about your text, like how many words in the text. On average, 20, on average about like 40 words in all those texts. And give you the summary score about the centimeter values. Right? Median is zero point 0.2, mean is also about zero point 0.2. Uh, then it also create like columns in your data. So create like columns, the columns data for your um as a centimeter score for your text. Right? So now it's includes a new variable. It's more like what I did earlier in R. So I created like a centimeter score, and then I use centimeter score now for analysis. And then you can draw the diagram directly, but instead of use the comments, you can change this to be the comments um, sentiment, and then it becomes a regular SEM model, right? Uh, in addition to this dictionary-based method, you can also do this using the sentiment AI method. You can also like directly embed and encode your data. Okay. Um, we actually have a lot of encoders you can use. So, so those two are included in like um, in our R package, but you can also we can also include many others we didn't install it yet. So once we install that on our server, you can also use some other methods. So after encoding, it also create a embedded data set. So this will take a long time. So I'm not going to like run this. Okay. So this is embedded data, okay, saved as a data set. So it take about 1.66 megabytes of space. So it's a large data set. Is 500 by, I think is 500 by 784 matrix. Okay. I already talked about this. And it's slow, like for doing this. The reason is because our server is um, we only allow you to use a single core, a single process to embed the data, so you cannot take advantage of the parallel computing on our server. On your own computer, probably is much faster. You can also use a sentiment AI package um, to get the sentiment score. So it give you the um, it give you the summary statistic for the sentiment score. And we also create a new column called the sentiment AI in your data set, so you can use like in the future. So notice that the reason we include this like process is because we found like some users cannot install like a sentiment AI correct on their computer. So which means it will prevent them from using the our package. So if we use this, if you do this on our computer, our server, it's guaranteed to work. So once you get the scores, you can download the new data set. Okay. For example, once you have a new data set, we have a sentiment AI sentiment. We have like a dictionary-based sentiment. And then you can download this data set to your computer and then use that in like any software, like M plus even, or use that in directly in R in Lavelle. Uh, I already showed you how to do like this data analysis. So basically, you need to draw this model. Um, I included some videos. I don't I probably I won't play this for you like here, but I will share like the videos on the mailing list so you can watch that later like so it will show like the basic process. Okay, just play play one of that. Okay, so to show you the process of doing the data analysis. So what this one does is do a median analysis. So you can first select the variables, select the data set. So once you select the data set, you click this button. It shows all the variables in your data set. So you can simply click on the name of each variable. And once you did that, your variable will show in this like plotting area. Because every variable in the data set is an observed variable. So therefore it put a square here. Then you can move this around at the connections between like those variables. So at the path from difficult to this, and then at the path from common to written. Right? And you can name the path, use different names. Just double click on this. I'll give you A. Double click on this. You can set up B here. You can move this around. You don't have to do this, but if you want to make your path diagram look a little bit like better, prettier, you can do that. And then you can save the model. Here, just called like mediation example one. Okay. Then this is your model, and then you can specify something else. So the constraints AB equal to A times B. So that's the mediation effects. Then you need to specify your text variable. So my text variable is comments. We can actually automatically identify the text variable, but that's not like safe enough. So we ask the user to specify that to make sure like the analysis is accurate. Okay. Um, and then you can see the uh, results here, just like what I showed you earlier. Okay. So this is the video demonstration. Okay. This video is also on website too. We have a menu for how to use the R package, how to use the online-based method. Okay, so I'm going to close this. Okay, this is for the dictionary-based method, AI-based methods. There's also video for that too. Do not open this. Save time. You can also do a fact model. Okay, here I use a fact model. So um, the F1 is the teaching performance. Teaching performance is measured by both text comments and the text. Okay, and also like kind of like by ratings too. And in SEM, as we know, we cannot distinguish this as an outcome or as a predictor. Right? If you think like this is a mediation model, that's fine too. Okay, so you can get the mediation effects. And so this is a video to show you how to draw this model, how to run this model. Uh, we can you could also like using a programming interface, just like you are using R to do the data analysis. But currently we disabled this. The reason is um, there's some like security issues. And if we don't disable this, some people may be able to see our data using R. So before we figure out a way to fix the security issues, so we just disabled this feature. Okay. Um, so that's all what I want to show you like in this workshop. So to summarize, we know there's a lot of information available, text information available, right? And almost anything, the majority of the information like in the world is uh, expressed as text. There are also many new methods available to automatically uh, process the text data. I showed you some methods like embedding is probably based on the transformer, probably is the most powerful method to automatically process text data. And even with that, uh, the text data are still not well utilized in particularly in research. Right? The reason is there's a gap between the method developed in computer science and the model used by like applied researchers. And what we did is we basically developed the methods to kind of incorporate like or combine the computer science methods with like psychometric models so that we get a new like SEM framework. Okay. When we use this method, we actually like make the utilization make the use of the text information like easily possible. I hope like with the example I showed you, I convinced you like it's actually rather easy to do like SEM analysis text. And at the same time, we also make like the machine learning or the AI-based method more interpretable. You can think about once you add like other variables to explain the text information, or use the text information to explain outcome. In either way, you actually make like uh, your your information more like informative, right? It's easier to like to tell a story. Yeah. And we also developed the BigSEM online app. Okay, this online app can quantify like text data using different methods. They can also like using such information in SEM model directly, right? And we hope like this method will open the opportunity for you to use like text data in your own research to answer like um, novel questions, right? Certainly, like we can still improve our methods in different ways. Uh, for example, we may incorporate like better methods to make the model like more interpretable. For example, now we use like centimeter scores. Centimeter score again, like still we can see like how much information explained, but exactly how this is related to how this mediator works can still be studied. For example, we may identify words related to this centimeter scale, so makes this uh, interpretation easier, right? And we will also continue um, develop our R package and our labs to make it more powerful and easier to use. Um, Finally, I want to thanks like my collaborators like Hihai Yuan, Li Juan, and particularly like Ningbo. Um, Ningbo has worked on these methods like during the past several years, and she's now she will start as a professor at Wisconsin Medicine, and you will see like her work like in the future too in publication and some other students. And this project is also supported by IES